Hello students, this is Dr. Syed from Sanjani College of Engineering, Kopargaon. In this lecture, we will discuss one numerical example on analysis of two hinge parabolic arch and how to calculate horizontal thrust, normal thrust, radial shear, and at the end how to plot the bending moment diagram. So statement of numerical is a two hinge parabolic arch of span 24 meter and central rise 9 meter carries a point load of 10 kilonewton at the crown. Calculate horizontal thrust. Also find out the bending moment, normal thrust and radial shear at 6 meter distance from the left support. Okay, and at the end to plot the bending moment diagram. This is the arch given where support A and support B are hinge. 10 kilonewton force is acting at the crown. Span of arch is 24 meter and this is called as central rise, that is central height, that is 9 meter. Question is to find out the horizontal thrust, normal thrust, radial shear and bending moment. So very first step is to calculate the reactions at support, vertical reactions. As we discussed in the previous problem, reactions at hinge support are 2, but at hinge support horizontal reaction is nothing but horizontal thrust. Similarly at support B, horizontal reaction, this is horizontal thrust. Okay, and vertical reactions at A, let assume RAV, and vertical reaction at B, let assume RBV. Okay, so we have to calculate vertical reactions at supports by using your basic principle of engineering mechanics, and then to find out horizontal reaction is nothing but horizontal thrust. We also discuss horizontal thrust at support A is always towards right and horizontal thrust at support B is always towards left because of this 10 kilonewton downward force, these two supports are trying to move towards left and right respectively. Okay, so we'll start the solution with the very first step. We can use the direct basic engineering mechanics equations, that is summation of Fy equal to 0, equations of equilibrium, and summation of moment equal to 0, right? So if you take summation of Fy equal to 0, this plus RAV and this plus RBV vertical reaction is equal to downward force 10 kilonewton, that is first equation, and summation of moment about A, so moment of 10 kilonewton is 10 into half of the distance is 12 meter, okay, clockwise is taken as a minus, and RBV into 24 meter perpendicular distance anti-clockwise is taken as a plus. We can change the sign conventions, no problem. So from this we can calculate the vertical reactions at B and A, that is 5 kilonewton each, right? We can use directly standard formulas. If a structure subjected to symmetric load, the total load is equally taken by both the supports. So vertical reaction is half at A and half at B. No need to apply these two equations. Directly we can write down this is 5 kilonewton RAV and 5 kilonewton RBV. Okay, because 10 kilonewton load is acting at the center. Now to find out remaining two reactions, that is horizontal reaction at A and horizontal reaction at B, which is also called as horizontal thrust. So we already discussed in the previous problem, there is a standard formula to calculate the horizontal thrust. Integration m into y dx upon integration y square dx, where y is the vertical distance of any point on the arch. So if you select any point anywhere on the arch, if you find out its vertical distance from the horizontal line, this is y. Okay, and x is a horizontal distance, this is x, right? And m is a value of moment if you take a section at anywhere or at the same point where you are calculating the y. At this point, if you take a section and take a moment of left zone and right zone, that is m. Okay, so like this we can calculate the horizontal thrust. Now for this problem, if you want to calculate, now suppose if we select one point here, okay, now its vertical distance y is this, and this is x distance. This is x and this is y. Vertical reactions we already determined. This is 5 kilonewton and this is 5 kilonewton. Now our question is to find out horizontal thrust, that is h, this one. Now using the formula vertical distance at any point of the parabolic arch, the equation is y equal to 4h upon L square into Lx minus x square, where h is the value of central rise, that is 9 meter given to you. This is h. L is equal to span of arch, that is 24 meter is given to you. So if you substitute 4 into 9 upon 24 square in bracket 24 into x minus x square, this is the value of y you will get 0.0625 in bracket 24x minus x square. Okay. Now to find out the horizontal thrust, we have to take a section and we have to integrate that moment from left support to right support. So since point load is acting on the arch, we will divide this into two zones. One zone is left, that is A to C, and second zone is B to C or C to B you can write down. So A to C and B to C, there are two zones. We have to take two sections. One section is in the left zone and one section is in the right zone. So here if you take a section at this point in left zone, that is A to C, and here if you take a section in B to C zone, this is the point. Okay. Now how to write down this? Now A to C zone limits are at A support, if you assume x equal to 0, at C point we are getting x equal to 12, right? So limits of this integration will be 0 to 12. Okay. Now we are taking moment here. If you consider the left portion of this section for the moment, consider only left part, forget about the right part. Now on left part you will be having these two forces. Out of these two forces, since we are calculating horizontal thrust, we are not considering this while taking the moment. So only force remaining is this vertical reaction, that is 5 kilonewton. Okay, this is horizontal distance x. So what is the moment? Moment will be 5 into x. When we are considering the left zone, that is A to C, sign conventions will take clockwise as a positive and anti-clockwise as a negative. Okay, and when you consider the right zone, we will take anti-clockwise as a positive and clockwise as a negative. These are the sign conventions we already learned in mechanics of solids while calculating shear force and bending moment diagrams. Okay, left zone clockwise plus, anti-clockwise minus, right zone anti-clockwise plus, clockwise minus. So coming to our point, left zone we are considering, we are taking section here. So force which is to be, moment of force which is to be taken is 5 kilonewton. 5 into perpendicular distance is x, and this is vertical force creating the clockwise moment about this point. Let us assume this is point D. It is creating the clockwise moment, so 5 into x. Value of m is equal to 5 into x, and this is y which we already calculated here. This y is as it is. Okay, now half of the arch is over, that is A to C. Now remaining half of the arch, we can use the logic of symmetry. If it is a symmetrical load acting on the arch, this moment will be exactly double, twice. Or if it is unsymmetric, we have to take a moment of right zone separately. So here it is symmetric, but we'll see that how to take moment in the right zone also. So now we are taking one section in the right zone, that is B to C. This is the zone. We are taking moment at this point. This is the vertical distance y of that point, and this is horizontal distance x. Now if you consider the right portion of this, when we are taking section in right zone, consider the right part. When we are taking left section in left zone, consider the left part. So if you consider the right part of this section, look at the right part, there are again two reactions. Out of that, this is H, horizontal thrust, so we are not considering this while calculating the moment. So only vertical reaction again, 5 kilonewton, moment is 5 into x anti-clockwise. As per the sign conventions, on the right part anti-clockwise is plus, so 5 into x again. So zone BC, moment equal to 5 into x, y equal to same. So if you look at these two zones, the moment m into y is same, exactly same. That's why I told you, if it is a symmetric load acting on the arch, it may be full span UDL or it may be central point load. The value of this m into y, you can take double and consider only half of the arch, one zone, that is A to C. Okay, so like this we can calculate m into y, limits are 0 to 12. So finally we can write integration m into y is equal to 2 times, out of these two any one integration we can consider, so 2 times 0 to 12 this value. Now if you perform this integration in your calculator, even manually, you will get the answer of this is 5400 kilonewton. This is the answer of integration m into y dx over the limit 0 to 12. Okay. Now, so this is the numerator of our horizontal thrust formula. If you look at in the previous slide, this one. So now 5400 we calculate the numerator. Now our job is to calculate the denominator, that is integration of y square. So to calculate that, y already we calculated here. So y square means square of that. This is square. Now limits of y square integration are complete from support A to support B, that is 24. It's not 20, it is 24 meter. Please make it correct. It is 24 meter. Right? 24. 0 to 24 y square. From left support to right support. So if you put this value of y here, and now if you integrate this, first you have to square this bracket and then you have to integrate. You can solve this in your calculator, and if you find out the answer, your answer is coming 1036.8 kilonewton. The answer is correct, only limits are by mistake it is written 20, it is 24. With the same limit we are getting answer 1036.8 kilonewton is the answer of denominator integration of y square. So now if you find out horizontal thrust with the formula, H is equal to integration of m into y dx upon y square dx. So 5400 upon 1036.8, your answer is you are getting 5.21 kilonewton is the value of horizontal thrust. Like in previous problem we discussed, we can verify the answer by using the standard formulas of horizontal thrust. The standard formula of horizontal thrust is 25 into W into L upon 120H, where W is the point load, L is the span of arch, H is the central rise. So W equal to 10 here, L is equal to 24 meter and H is equal to 9 meter. Okay, this H is equal to 9 meter, this is W, this is L. So if you put the values, you can check it, you will get the answer 5.21 kilonewton. So like this we can verify that our obtained value of horizontal thrust is correct. Okay. Now this is first unknown, calculate the horizontal thrust. Now remaining three unknowns are we need to find out, that is bending moment, normal thrust and radial shear at 6 meter distance from the left support. Okay. So bending moment at supports we know, since supports are hinge supports, bending moments are always 0 at the simple supports. Now to calculate the bending moment at 6 meter from the left support, if you take here 6 meter means here half of this left zone. So if you want to calculate moment here, what is the moment value at 6 meter? First we have to calculate what is value of y at 6 meter. This distance is known to us 6 meter. Okay. So using the equation of y again, in the previous slide we discussed. Using the same equation of y, if you put here h and L square, L and x value is 6 meter, So you will get y, vertical distance of that point, that is 6 meter from the left support. The vertical coordinate will be 6.75 meter. Right. Now we are taking moment here. If you take a section here, if you consider the left portion, now there are two forces. One is horizontal thrust and one is vertical reaction. Horizontal thrust moment is anti-clockwise and 5 kilonewton moment is clockwise. So if you write down the equation of moment, 5 into 6 clockwise is plus and 5.21 into 6.75 vertical distance. So the answer is coming 5.17 kilonewton meter. So if answer coming minus, it means this moment is anti-clockwise, because we have considered clockwise as a positive. So this is second unknown, bending moment at 6 meter from the left support. Now there are two more unknowns, normal thrust and radial shear. Okay, even if you want to plot the bending moment diagram, we need the maximum bending moment also. Maximum bending moment, that is at the point C. So if you want to calculate maximum bending moment at point C, if you take a section here and if you consider the left portion again, the answer will be 5.21 into 9, that is anti-clockwise, and 5 into 12, that is clockwise. So you can find out the maximum bending moment. 5 into 12 clockwise is plus, 5.21 into 9 anti-clockwise minus. The answer is coming 13.11. Answer is positive. It means this moment is clockwise. This is anti-clockwise at 6 meter and this is clockwise at C point. So both the moments we have calculated. We can plot the bending moment diagram using this. This is the bending moment diagram. Since it is a central point load, it will be a triangle. Here we got the moment 13.11, that is positive, and at 6 meter we got it is minus, its value is 5.21, right? In previous slide we have seen 5.17. This is the moment at 6 meter, 5.17. Okay, this is minus and this is plus. So this is final bending moment diagram. Now we have two more unknowns, normal thrust and radial shear at 6 meter again. So we have taken a section. Let us assume this point is D at 6 meter. Okay. Now this y coordinate also we have calculated, that is 6.75 in the previous step, 6.75 meter. Okay. Now we have to find out what is the slope at this point. If you draw a tangent to the arch, what is the slope at this point, that we have to calculate. So there is again a standard formula to calculate tan of theta equal to 4h upon L square in bracket L minus 2x, where h is equal to 9 meter, L equal to 24 meter, x equal to 6. If you put all these values here and if you find out the theta, your answer is coming 36.87. What this theta represent? This theta is slope at point D. This is theta. Now using this theta you can find out the normal thrust 6 meter from the left support. The point where we have taken a section, at that point one vertical shear force is acting, which is represented as a Vx. Okay. This vertical reaction of arch is 5 kilonewton. This is horizontal thrust, which is equal to 5.21 kilonewton, that we already calculated. Okay. By using summation of Fy, you can calculate the Vx also. Plus 5 minus Vx equal to 0. So answer of Vx you are getting 5 kilonewton again. This is also 5, that is using summation of Fy. Okay. Plus 5 and minus Vx equal to 0. So normal thrust is equal to, the standard equation is n equal to Vx sin theta plus h cos theta. Okay, so Vx equal to what we got? 5 again. Okay, this from summation of Fy we calculated. So Vx equal to 5 sin of 36.87 plus h is equal to 5.21. So h 5.21 cos of 36.87. So answer of normal thrust is 7.17 kilonewton. Similarly, we can calculate the radial shear. The standard formula is R equal to Vx cos theta minus H sin theta. So Vx is 5 cos of 36.87 minus H 5.21 sin 36.87. So this is R actually, not N. This is radial shear, R equal to 0.874 kilonewton. This is the value of radial shear. So all 5 unknowns are over in the given numerical example. First unknown was to calculate the horizontal thrust, then bending moment, normal thrust and radial shear at 6 meter from the left support, that we have calculated. Bending moment answer was 5.17 minus, normal thrust answer is 7.17 kilonewton and radial shear is 0.874 kilonewton. We also plot the final bending moment diagram. Like this you can solve the problem of 2 hinge parabolic arch. Okay. In the next class we'll solve the one more numerical example. Thank you very much.